Hello, welcome to the new video, Optical Flow-Based Tracking. In the previous video we have built an interactive object tracker using cam shift. In this video we're going to learn about optical flow and its process. Then we will extract feature points and create tracking lines. Optical flow is a very popular technique used in computer vision. It uses image feature points to track an object. Individual feature points are tracked across successive frames in the live video. When we detect a set of feature points in a given frame, we compute the displacement vectors to keep track of it. We show the motion of these feature points between successive frames. These vectors are known as motion vectors. There are many different ways to perform optical flow, but the Lucas-Kinnaid method is perhaps the most popular. Here is the original paper that describes this technique. Create a new Python file and import these packages. Then define a function to start tracking using optical flow. Start by initializing the video capture object and the scaling factor. Define the number of frames to track and the number of frames to skip. Then initialize variables related to tracking paths and frame index with these lines. Define the tracking parameters like the window size, maximum level, and the termination criteria. Iterate indefinitely until the user presses the escape key. In this, start by capturing the current frame and resizing it. Convert the frame from RGB to grayscale. Create a copy of the frame. After that, check if the length of tracking paths is greater than 0. Organize the feature points. And compute the optical flow based on the previous and current images by using the feature points and the tracking parameters. Then extract the good feature points. And initialize the variable for the new tracking paths. Iterate through all the good feature points and draw circles around them. Append the x and y coordinates and don't exceed the number of frames we are supposed to track. Draw a circle around the point and update the tracking paths, and draw lines using the new tracking paths to show movement. Go into this if condition after skipping the number of frames specified earlier. Next, compute the good features to track using the inbuilt function, along with parameters like mask, maximum corners, quality level, minimum distance, and the block size. If the feature points exist, append them to the tracking paths. Update the variables related to frame index and the previous grayscale image. And display the output. Check if the user pressed the escape key. If so, exit the loop. Finally, define the main function and start tracking. Once you stop the tracker, make sure that all the windows are closed properly. Go to Command Prompt and run the code. If you run the code, you will see a window showing the live video. You will see feature points similar to this. If you move around, you will see lines showing the movement of those feature points. If you then move in the opposite direction, the lines will also change their direction accordingly. You can see it is just visible for a few seconds, and then it's gone. So our optical flow-based tracking was successful. In the next video, we will perform face detection and tracking.